Dear students, welcome back. In the previous session we have discussed about the triode valve. Now in this session we are going to discuss about semiconductors. These semiconductors are usually metals, and these semiconductors are defined as the materials that are neither conductor nor insulator. So it is having the conductivity capacity in between these two things, like in between conductors and insulators. We can't say the semiconductors, the name itself mentioned that semiconductors. So here the materials are not as good as the conductors, and also not as insulators, but these materials will have some capability of conducting capacity. Okay, so these materials are neither conductor nor insulator with energy gap of about 1 electron volt. They are called as semiconductors. Okay, so most common type of semiconductors are made up of with germanium and silicon, because these elements will have the property to withstand high temperatures. Okay, for that reason these two metals are used. Okay, so how it conducts the electrons. Okay, now we will see. So these semiconductors are usually metals. Because of thermal agitations or addition of impurities to having in these metals, causing in these metals. So what do you mean by thermal agitation? There is a constant or unending motion of atoms and molecules in the object at a temperature above absolute zero. So what do you mean by absolute zero? The absolute zero means 0 Kelvin or minus 273 degree centigrade. Okay, so at that time it causes them to emit or absorb radiation. So for that reason these semiconductors are used in therapeutic or biomedical apparatus. Okay, so because of its thermal agitation or addition of impurities have electrons free to conduct current. Okay, a semiconductor can either be of N type or P type. N type or P type. In a N type semiconductor, there is an excess of electron which carries current, whereas in P type the deficiency of electrons gives rise to positive holes. Okay, due to which current flow occurs. So in the N type, what is having? There is an excess of electrons which carries current. In the case of P type, there is a deficiency of electron gives rise to positive hole due to which current flow occurs. If N type and P type are fused together, electron can only pass from N to P. So these are the way how the electrons, because N type is having excess of electrons and P type doesn't have electrons, but it is having a positive hole. That means it requires some electrons. So the electrons in N type will move on to the P type. Okay, so and this semiconductor therefore acts as a valve. Why? Because there is an unidirectional flow of electrons is taking place. Only from N to P the electrons are moving, not from P to N. So this is the reason the semiconductor is also considered as valve. Okay, if you see in detail about this N-type semiconductor and P-type semiconductors, first we will see the N-type semiconductor. Yes. So in this N-type semiconductor, an atom of silicon, okay, an atom of silicon with atomic number 14, which has 4 electrons in the outermost shell, okay, and in a crystal of silicon, so this is the crystal of silicon, these are held in forming bonds with neighboring atoms. So these are forming bonds with neighboring atoms. For example, this is the silicon and it is having 4 electrons, outermost electrons. It is forming bonds with 4 atoms, isn't it? Yes. So that there is no free electrons to transmit an electron. So, when certain other materials such as phosphorus, so here phosphorus with atomic number 15 with 5 electrons outside or added to silicon, it transmits current. When silicon and phosphorus forms covalent bonds, 4 electrons of phosphorus, okay, make bond with 4 electrons of silicon, leaving behind 1 free electron in the phosphorus, which are not held in bond with other atoms, therefore carrying current when connected with a source in the same way like the conductors. Such a material is called N-type of semiconductor. So what is here? 1 electron is remaining and this electron is going to transfer, okay, to the other source. Okay, so such kind of semiconductors are called as N-type semiconductors. Okay, now we'll move on to the P-type semiconductors. So when silicon is added with certain other substances such as aluminum, so this aluminum is having an atomic number 13 and it is having 3 outer electrons in the aluminum atom. It makes bond with 3 electrons in the silicon outer orbit, isn't it? So what happens? So whereas the 4th electron of silicon, there is no electron available on the outer orbit of aluminum, creating an electron deficiency hole. Here it is creating an electron deficiency hole. When a potential difference is applied to such material, electrons move from some of the atoms into these unoccupied bonds or holes nearer to the positive poles, so that as the electrons move away from the negative towards the positive, the holes move from the positive towards the negative, constituting the flow of current. Okay, so that is the thing happening here. The movement of positive holes from positive towards negative is equivalent to the movement of electrons from negative to positive. The material that transmits current in this manner is called a P-type semiconductor. Okay, so here we can see the semiconductor diode also. So normally the semiconductor diode is made up of like this only. So N-type and P-type fusion will get this semiconductor diode. Okay, so when an N-type semiconductor which has free electrons is placed in contact with P-type semiconductor which has positive holes, electron move from the N-type to occupy the positive holes in the P-type, while the positive holes move in the reverse direction. When the positive holes moves in the reverse direction. In this device, the current can only pass in one direction, from P to N, that is from P to N, and such device is called as semiconductor diode. Okay. Here the electrons are moving from N to P type. Okay, so N to P. In this device, the current can only pass in one direction, that is from P to N, and such device is called as semiconductor diode. If you see the construction of this semiconductor diode, you can understand well. Okay, when the semiconductors of N-type and P-type are connected to a source of EMF, so these two are connected to the source of an EMF, the potential difference at their junction affects the current flow. If the N-type semiconductor is made more negative than the equilibrium value and the P-type is more positive, electron lost from the N-type are replaced from the supply, while excess electrons are withdrawn from the P-type to the supply. So whatever the electrons which are present in N-type is taken by the P-type, okay, and the lacking electrons which are present in the N-type are taken up by the source of supply. Okay, and the potential and the positive electrons lost from the N-type are replaced from the supply, while excess electrons are withdrawn from the P-type to the supply. So if the electrons are excess in the P-type, that one is taken back to the source. Okay, so that is why the type of flow of current is again P to N in this type of conductor. So the potential difference at the junction is reduced. Electrons are able to pass from N-type to P-type. So if the source is removed, then only the flow is N to P, and current flows across the circuit. If however the P-type semiconductor is negative, so if this one is negative relative to the N-type, the potential difference at the junction opposes the electron movement and no current flow until the applied potential difference reaches a certain critical value. Okay, so current can only flow only when N is negative and P is positive, constituting a unidirectional flow like a valve. So it is called as semiconductor diode. Okay, so this is all about the semiconductors. Okay, in the next session we are going to discuss about the transistor. It is another electrical device. Okay, so we will discuss the transistor in the next session. Thank you.